Welcome back, students, to my course, and with this video we will start our practical tutorials within module 12, remote sensing indexes, application of remote sensing indexes. So remote sensing indexes are widely applied and widely used by GIS specialists. This can be due to several reasons. This can be used for ecological and conservation purposes, biodiversity, climate change, and also precision agriculture. So open at first ArcMap document, tutorial 12, remote sensing indices, and here you can see two data frames, 2016 and 2020. I already added here all Landsat bands, which I downloaded from the Remote Pixel CA website. So here you can see that bands from bands 2 and to band 7. This is for year 2016, and also for 2020, also from band 2 till band 7, and I grouped all bands into one group. So also we have here is a shapefile of the urban area, huge agglomeration of a city. So basically first we will work with vegetation indexes, and then we will continue with the urban and water indices. So we will apply them all. So at first we should composite our bands. Composite bands, it means stack layers. We have here all layers in a separate files as TIFF files. So it's not a composite band. Group is not a composite band. If you remember from the first modules, making groups from layers. But we're compositing bands. It means that all the layers or all the bands of one image from the same area and same time, we will make one image. Into one, we will merge them into one image and give them each band, 3 of these bands, one color from RGB color, red, green or blue, in order to represent them on a window. So in order to composite band, let's open search and right here composite, just enough, composite. So here you can see composite bands, the tool which will help us to stack layers. So let's here is a group, and let's start from the second band. This is a blue color, green, red, near infrared, sphere, and sphere 2. So let's see, let's write here composite bands 2016. Sorry, this file is already exists. So let's write here Landsat just 2016, right? Landsat 2016. So now our GIS stacking layers. So our layers are stacked together. See, Landsat 16. So I will close this group. So see that this is all the one image. See, one image in format FGDBR, and the size of this image now is approximately 700 megabytes. While the size of this image, these bands, approximately 70 megabytes. So see when the layers are stacked together, ArcGIS assigns to each band color, either red, green or blue. See, but this is not actually, we can see here true color composition. Let's open properties, go to symbology, see that it assigned to band 1 red color, while actually band 1 is a band 1 is a blue color, while red is a band 3. So I will change red color to band 3, green color is band 2 is correct, and blue color is actually band 1. See, now our representation of an image of array changed. Now it's seemed to be a true color. True color, when you assign to each color, we can see in a physical world, it's a natural color, it's actual color in corresponding color in ArcGIS. For instance, to red you assign red, for the red band you assign red color, for the green band you assign green color, and for the blue band you assign blue color. It's called true color composition, whereas we can also change the composition of our bands. We can change it into false color. For instance, I want to see represent the near infrared band as a red color, right? Red color, and to green color I will assign the red electromagnetic waves, and to the blue color I will assign green electromagnetic waves. I click OK and see that these areas now colored by red color, because they are all vegetation. See that it's agricultural areas. Also here there are also pastures and meadows, because the vegetation mostly reflect near infrared, and as you may remember from the lecture, in order to find vegetation, the main basic principle of vegetation indexes, including NDVI, is finding the ratio between near infrared and red, because the vegetations absorb a lot of red color energy and reflects a lot of near infrared color. Therefore, when we assign it to red color near infrared band, all vegetation areas are colored with red color, while this areas seems to be mostly mixed with green and blue. So and also red, because we assigned to the red color green one. So this is called false color composition. Also we can change, for instance, like this, to red color I will assign band 6. This is shortwave infrared 1, shortwave infrared 2, and also near infrared. Let's see. So red color is sphere 1, green sphere 2, and the blue one is near infrared. So see, now is all vegetation areas are colored by blue, because they reflect a lot of near infrared energy, while we can see here that these rocks and stones and some minerals are colored by green. This is short wave infrared, the first band of short wave. The red color is the short wave infrared 2. While the green color is shortwave infrared 1. So these are mostly reflect shortwave infrared 1 spectral range of electromagnetic radiation. And there is also a minimum amount of shortwave infrared 2, because I don't see here a red color. See? So this is also called a false color composition. So I will go back to my my true color composition, and let's start our vegetation analysis. In order to start vegetation analysis, you should there are several ways to apply NDVI and other indices in ArcGIS. The most easiest way is to click to Windows on the menu panel and click to Image Analysis. See, it's my image analysis already open, and here is my composite of bands. See, Landsat 16, and I will go to Options, and here is NDVI. You can see Image Analysis Options, NDVI, and the red band represented by the red band is the third band, right? Infrared band is the fourth band. So I will check again. Let's open. So red band is the blue. Oh yes, band 3 is red. I mean, the red color is band 3, and near infrared also band 4. We already. So this is band 4 near infrared. So click here scientific output, and now here is leaf button, NDVI, compute normalized difference vegetation index. So now we can click to this button, and it automatically calculated our NDVI image. So from -1 to +1. But see, you can see that high NDVI values are colored by white, and we already recognize that these areas are vegetation, full of vegetation, mostly agricultural areas, and this dark colors represented by my minimum vegetation. And we can see here that water areas, because they reflect almost do not reflect near infrared energy, will always be colored by dark colors. See, water doesn't reflect near infrared energy at all, in contrast with the vegetation. See, this is also water area, and almost no vegetation, no C minus values, no NDVI. So but you should know that this is temporal NDVI image, NDVI Landsat 2016. In order to make it constant, we should save it. Click to export. See, we can see the export raster data, Landsat 16. No data is okay, we will stay here. Cell size 3030, right? Correct, because it's a Landsat image. So, and I will should also choose here the location. So NDVI 2016. So it could no, sorry, I should find choose here and just folder. So Landsat. Now I will put here NDVI 2016. So TIFF. So click so just meant export will add no data pixels to the output raster dataset. In order to store the no data pixels in the output, pixel depths will be promoted. Do you want to promote the pixel depths and export? So no, I don't want to promote. Anyway, we will extract the urban area from the just total image, total coverage. So it's now export. By the way, I made a mistake here. You should choose this NDVI. So you should export those image that is temporal. So Landsat is constant, we don't need it. We should export NDVI. So here is NDVI Landsat images, and click OK. So no data is just do not put here values from -1 to 1, because we need this data. But just you can click no data as no data. That's it. We don't need it. So let's click OK. So my NDVI map is exported. See, it says we can already delete this one, and this one is constant. This is my urban area, and we can also change the color ramp. Let's go from stretched to classified. See, we can see here 5 classes. Let's go to classified tool. So we can change it to manual, and let's pick classes. So from minus areas to, let's do 0, right? This one is 0. So minus areas actually from minus, okay, let's put from to minus 0.2. This will be water and glaciers. From -2 to 0, this will be mostly urban and asphalt. From 0 to 0.2, this is bare land. From 0.2 to 0. So it's 5, let's make it. This will be grasslands, meadows, etc. So now it's clear. We can change here the label. So this will be water and glaciers. This will be urban and rocks. This will be bare soil or bare lands. This will be grasslands and meadows. This will be forest. So, and also we can change here the color. So let's make it not white, not see, now it's clear. So this is my final map. This also can be considered as agricultural lands, right? And you should remember that agriculture always have smaller vegetation, NDVI, comparing to forest. So no, it's should change a little bit values to not -2 to but minus. We can minus 0.1. Okay. Red urban, and this one is blue. So now it's correct. So this is water, so you can see water areas. This one actually should be urban. Okay, let's make it stretched again. Put color ramp to this one. So this no, it's not appropriate color ramp. Choose this one, is more appropriate. So green areas represent a lot of vegetation here. This red area is no vegetation at all, and this yellow area is just average vegetation or just bare soil and bare land. So repeat the same steps with 2020. I will pause the video here. So I also created a NDVI map for 2020, and let's add a new data frame and just drag this NDVI image to our new data frame. Also this one. And also let's drag our shape file of urban area. So, and we should extract this area before comparing two NDVI images with each other. Let's go to Spatial Analysis tool, Extraction, Extract by Mask, and choose at first one file, 2016, as a input raster or future mask data, urban. So urban NDVI 16. So it's extracting. See, the file is already extracted. I can close this one. This is NDVI values for this small area, urban agglomeration, and do the same thing with the 2020 urban NDVI 20. So my files are extracted and I don't need the other larger image so far, and so these are our both NDVI image for 2020 and so by the way, you can use a snip snip tool here. No, it's not actually. So this one is snip tool. So we can just compare two images, right, with each other, 2020 and 2060. See that the region in 4 years are changed really. And now I need a raster calculator to compare both images with each other. Let's go to spatial analysis, map algebra, raster calculator, and don't forget to use at first float function, because these numbers are float. In our case, ArcGIS can show you an error. So urban change, no, not urban change, but NDVI change. NDVI change, and let's click OK. So see, this is NDVI change, so from minus to minus value. So let's go at first to symbology, classified. Let's make three classes from minus to, this will be minus area, so let's make it minus 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 0 1. It's almost 1, and also a 0. So this will be the first from minus to till this area. See that this area, and also almost values close to 0. Let's make, we can also add 1 0 again. All right. And value that will be above 0, below above 0. So, and this will be red one because this vegetation is degraded. This will be gray because neutral, no degradation and no surplus, and this will be green, vegetation surplus. So we can see here, by the way, some areas are really degraded, right? These areas. And some areas, most of the areas actually, we can see that vegetation surplus. Let's go to image analysis. Let's compare with again. It's hard to say for sure. Is it a surplus of energy, surplus of vegetation? It's actually hard to say. We can compare also mean values of can go to histogram. So this is mean value 0.14 standard deviation, and NDVI 14 histogram 0.13. so actually a little bit surplus of vegetation here, a biomass during the last 4 years, which is surprising actually. So I will pause the video here and let's continue with the following video with urban and water indices.